afternoon. I'm Spot On Weather meteorologist Matthew Euler, and it's time to take a look at the Spot On Weather 2020-2021 winter outlook. What will this winter see? What will we see this winter? Well, let's go ahead and take a look, and I'll get into all the details of what we're looking at. So we'll go ahead and move along to the next slide. All right, so for my winter outlook considerations, and I'm considering winter to fall in lines more with meteorological winter from the 1st of December to the end of February. These are our considerations in this year's outlook. First thing is a La Nina is forecast. We have a greater than 70% probability this winter of seeing La Nina conditions. North Atlantic Oscillation, the NAO, and the Arctic Oscillation, the AO phases, are taken into consideration in the development of this outlook. The Pacific North American, the PNA, and the Madden-Julian Oscillation, the MJO phases. We take a look at low solar activity and factor that into the winter outlook. And low solar activity, per research, is typically associated with high latitude blocking into the northern oceans, the North Atlantic and North Pacific, along with a weaker polar vortex. Additionally, we look at the hurricane accumulated cyclone energy, the ACE, which has to do more with the potential energy availability for the East Coast winter storms, and also Southeast Ridge being more of the dominant player versus a upper level trough along the East Coast. Next, we'll go into the sea surface temperature anomalies, with this year's winter outlook primarily focused on the below normal water temperatures along the equatorial eastern Pacific, so we'll go more into that. And finally, we'll look at the polar vortex and stratospheric warming events and what we're projecting for this upcoming winter. Let's first start the video by taking a look at the summary of last winter, December 2019 to February 2020. The image on the graphic on the left shows December 2019, difference from average temperatures in degrees Fahrenheit. The graphic on the right shows January 2020. Difference from average temperature in degrees Fahrenheit. Now that maroon pinkish, looks like the salmon color there, that indicates well above normal temperatures. So for both the months of December as well as January, we saw really an incredible swath of above normal temperatures across a large area of the United States, specifically in the upper Midwest, the Ohio River Valley, as well as the eastern seaboard. It really had people wondering last winter, why is it so mild? It's unbelievable how mild it was. Part of the reason for this was the polar vortex remained strong over the Arctic region the entire winter, and this kept the coldest air bottled up over the far northern latitudes. Additionally, the Madden-Julian Oscillation phase, which has to do more along the lines of convection in the equatorial Pacific and the Indian Ocean area, the MJO phase remained amplified in the warmer phases for a second consecutive winter. Moving ahead, the image on the left here shows February 2020, temperature departures from normal, and the image on the right, actually moving forward, the image on the right shows temperature departures from average in degrees Fahrenheit for the month of April. And so the graphic on the left shows again the mid-Atlantic up to the New England states in February 2020. We saw temperatures well above normal. It did cool off in February of 2020 across the Rocky Mountain states, there in Wyoming, Colorado. So it did show some cooling at that point in February 2020. But the graphic on the right, this is really becoming a common theme lately. We're typically seeing above normal temperatures in the wintertime across the eastern U.S. And the graphic on the right shows how cooler than normal temps did not arrive until April of 2020. That's that blue shading, which is, again, becoming a more common trend or theme. Mild eastern winters and cool below normal eastern U.S. springs. Here's a look at past snowfall for Virginia Beach. I wanted to go ahead and I measured this personally and did recordings in the COCORAS program. These are water year summaries. The graphic on the left, I want you to pay attention to the purple vertical bars in both the graphic on the left and the graphic on the right. The graphic on the left is the water year from the 1st of October 2016 to 30 September 2017. And you'll notice that graphic on the left, that purple bar shows 17.5 inches of snow, which we received in January of 2017. And the graphic on the right shows the following water year summary. Again, January was a big month on that graphic on the right. In January 2018, we saw between 10 and 12 inches of snow for the month. Now, typical average snowfall in a winter in Hampton Roads is about 7 inches. So we have seen a snowier January 2017 and January 2018 time period. Again, that purple, pay attention to the purple graphic, that purple bar shows the snowfall totals. We were well above normal in January 2017, and that's just in January, and again, well above normal in January 2018. Now, 2019, we really didn't see much in the way of snow. The winter of 2018-19, as well as the winter of 2019-20. Let's take a look at sea surface temperature anomalies now. This is courtesy of Tropical Tidbits website. The orangish shading, the orange shadings, the orange colors represent above normal sea surface temperature departures, and that is in degrees Celsius. So you see the orange shadings along the U.S. West Coast, down off of Baja in Mexico. You'll notice the blue color there, however, to the west of South America in the equatorial eastern Pacific. And that cooler than average, that blue shading that really stands out, is associated with the La Nina conditions that are currently ongoing. Now, La Nina will play a significant role, typically does, and any of the ENSO phases, whether it's El Nino or La Nina, play a significant role in our winter weather. Now, this shows you, this slide shows you the El Nino phases and the winter weather patterns associated with both El Nino on the left and the La Nina on the right during the winter. Being that we are now forecasting La Nina this winter, you can take a look at the graphic focus. You can focus your attention on the graphic on the right, where we see that blue line, which is your polar front jet stream. We have the Pacific jet stream really causing cool and wet conditions into the Gulf of Alaska, down the west coast of Canada, into the Pacific Northwest. And meanwhile, you have a polar front jet that dips down from western Canada into the northern plains and the midwestern states across to New England. Along the Gulf Coast, from Texas over to Florida, you typically see dry and warm conditions during the La Nina winter. La Nina is typically characterized by a negative ONI, or Oceanic Nino Index, of less than or equal to basically your 0.5 degrees Celsius below normal for water temperatures across that equatorial eastern Pacific, where this blue shading, that real contrasting blue shading, is located. And it occurs for 3 consecutive months in the Nino 3.4 region. And so I'll go ahead and move on to the next slide. Again, La Nina winter weather pattern. Again, this is just showing you another graphic. You typically have a blocking high pressure system in the Gulf of Alaska. The polar front jet stream is dipping down from Alaska and western Canada into the northern plain states. Along the Gulf Coast, you typically see a drier and warmer than normal pattern, as well as the mid-Atlantic states, including Southeast Virginia. We typically see a drier and warmer than normal weather pattern during La Nina winters. But I will caution that no two La Nina winters are ever exactly alike. There could be small nuances that could really change what happens in the actual outcomes. For example, a slight shift in the purple line there in this graphic, the jet stream, that could result in an entirely different outcome. Additionally, a blocking high into the Gulf of Alaska with that downstream trough into the Midwest and Northeast is quite common during La Nina winter weather patterns. So for Southeast Virginia, for the Mid-Atlantic, we would expect a milder and drier than normal winter with La Nina setting in. This is a look at the Climate Prediction Center, NOAA Climate Prediction Center forecast models. The graphic on the left shows the various models, all these different color lines. All are generally indicating a fairly good agreement for the months of November, December, January, as well as December, January, February, of sea surface temperatures in the eastern equatorial Pacific being 0.5 to 1 degree Celsius below normal, which meets the criteria for La Nina. And that red line shows the average of all the models, and note that you really don't come back into more of a neutral ENSO state until March, April, and May next spring. So you really can see with greater confidence with these forecast models that we're expecting a La Nina type of winter with those below normal water temperatures. If you look at the right-hand graphic, I'm showing you where the Nino 3.4 region is located. Generally is bounded by latitudes 5 degrees north to 5 degrees south, longitude 120 degrees west to 170 degrees west. The Oceanic Nino Index is based on those sea surface temperature departures from average in this Nino 3.4 region and is a principal measure of monitoring, assessing, and predicting ENSO. That's really what NOAA does and what they look at, the Climate Prediction Center, for classifying a La Nina versus a ENSO neutral year or an El Nino year. But here again, we have higher confidence that La Nina conditions, 70% probability, they will continue through the Northern Hemisphere winter. Additionally, when we talk about the winter outlook, we have to look at the teleconnections phases. I've done a lot of past videos on spot on weather for talking and describing about the North Atlantic Oscillation, NAO, as well as the Arctic Oscillation, the Madden-Julian Oscillation. So check our video library here on the Spot on Weather YouTube channel for older videos, which I really break down what these teleconnections mean. For example, the negative North Atlantic Oscillation mode graphic is on the left, and you'll notice the buckling or the trophy nature to the polar front jet stream, a major dip across the eastern U.S. during a negative NAO, in which you get colder and wetter than normal conditions for the eastern U.S. with that graphic on the left. And you typically also get that downstream blocking high into Greenland with a negative NAO. With a positive NAO on the right-hand side, you typically get more of a west to east oriented jet stream, more zonal west to east across the North Atlantic, across the United States, in which we see milder Pacific air infiltrate from west to east coast across the U.S. And we typically see warmer and drier than normal conditions for the eastern U.S. when we have a positive NAO. For the AO or Arctic Oscillation phases and weather, the graphic on the left shows a negative phase of the AO or Arctic Oscillation. That coincides with a major dip in the polar front jet stream across the Midwest to the east coast of the U.S., typically colder and stormier than normal with a negative phased AO. Image on the right shows a positive phased AO or Arctic Oscillation, more of that zonal west to east jet stream once more. Lower pressure, the coldest temperatures with a positive AO remain up over the polar areas. Here is a look at the NAO and AO. This is just recent history. The blue vertical bars there in relation to the zero line indicate whether the NAO and AO are positive or negative. The NAO or North Atlantic Oscillation, GFS observed in GFS forecasts, show the vertical blue bars mainly below the zero line down to about a -1 NAO phase or index here in early October. But mainly you see the bars below that zero reference line on the left-hand side with NAO. So more of a negative tendency as we head into October. The image on the graphic on the right shows the Arctic Oscillation. Again, you'll notice from like the 1st of October to the present time, we're looking at more of a forecasted negative Arctic Oscillation or AO. And both of those usually coincide with colder than normal temperatures across the eastern U.S. And we've actually seen a pretty chilly start to the fall season here across the Mid-Atlantic region. Here is the Pacific North American pattern of PNA, recent history on the left. And it's been kind of in and out, negative, and then positive, then back to negative again as we head into October, and then back to positive is the forecast, slightly positive by mid-October. Much more information about the Pacific North American pattern is on the right-hand graphic there, how it's a climate index associated with the fluctuation of upper-level heights observed over the U.S. Generally, you have positive, negative, and neutral phases of the PNA pattern, with a positive PNA resulting in a ridge across the western U.S. and a trough in the eastern U.S. As a result, with a positive PNA, you have increased chances of below normal temperatures across the eastern U.S., and you have warmer than normal temperatures across the west. With a negative PNA, however, if we have a negative PNA phase, we have increased chances of above normal temperatures across the eastern U.S., with our region being on the western fringes of the above normal temperature area. Meanwhile, you have a western trough and much chillier and below normal temperatures across the west coast of the United States with a negative PNA. So these PNAs are very important as far as how the jet stream sets up, a ridge versus a trough, and that's going to determine whether you have above or below normal temperatures across the United States, especially during the wintertime. Another teleconnection we need to talk about is the Matt-Julian Oscillation, or MJO. Now, this is a major fluctuation in tropical weather on weekly to monthly timescales. The different phases they go from 1 to 8, and it's really dependent on where the greatest, most active convection is located, and that is significant across the equatorial areas of the Pacific and Indian Ocean. Now, this is going to vary depending on where rising and sinking air occur in the equatorial Pacific, and that's going to change over time with the various Matt-Julian Oscillation phase changes, as well as what's known as the Kelvin waves that rotate through those enhanced convective areas and how they move from east to west across the equatorial areas of the Pacific. Additionally, there's difficulty in reliably predicting the phases from one winter to the next. That's what makes the MJO such a wild card in the winter outlook that I do every year. And it plays a significant role and sometimes is more dominant as compared to the other teleconnections, the AO, NAO, the PNA. The MJO can trump all of those. And, what happens in the Pacific Ocean really does have a huge bearing on the U.S. winters because of the fact that everything moves from west to east in the mid-latitudes. Milder phases for MJO are typically phases 3 through 7, while colder phases are typically 8 through 2. And that covers the December, January, February, the meteorological winter time period. Now, in recent winters, we have seen a tendency for longer-term warm phases and less amplified colder phases. We've seen the MJO really reside in those phases 3 through 7, the milder phases, in the past 2 winters. So as a result, we've really had quick-hitting cold shots, but then the air masses have been rapidly modifying and have been very mild once more. Look on the MJO phases. Again, December, January, and February are the months of consideration here. The graphic on the left shows what the temperature composites look like. The blue shading indicates below normal temperatures. The orange shading indicates above normal temperatures. Again, just showing phases 8 through 2 as the coldest coldest temperatures for the eastern United States, while phases 3 through 7 show very mild conditions for the Midwest to the East Coast. The graphic on the right shows the general ensemble forecast for the Matt-Julian Oscillation. Keep in mind that, again, you see each one of these sectors is divided up, labeled 1 through 8. So what I'm looking for here, the green line is the average of all the models. The yellow lines indicate the ensemble runs and the wide variety of possibilities over time. So right now we're situated in MJO Phase 5 here in early October, and it's expected to eventually rotate back and looks like it's heading towards Phase 6. So this is very important to take a look at. I'm always definitely looking at this teleconnection for the winter months because it has such a huge bearing on our weather. Additionally, I factored this in last year. I'm going to factor it in again this year. The low solar activity does continue. You look at where we are on the graphic here in 2020. The number of sunspots is very minimal. We're talking, next to nothing. If anything, single digits for sunspot numbers. We're entering solar cycle number 25. That red line there on the graph shows the predicted values and how we're in a lull in solar activity right now. And by 2025 and 2026, we'll be back with a more active sun again. Now, why do I look at solar activity in this outlook? Well, research has shown during minimum solar activity, like the period we are in now, a lower sunspot number, it's usually associated with high latitude blocking. It's more frequent with a negative NAO and AO tendency. Now, it didn't exactly work out that way last year. The MJO, as well as the strong polar vortex, pretty much dominated the winter headlines last year and kept conditions very mild across the United States as a whole. However, this is something that we need to consider in the outlook. Sunspot activity is forecast to remain very low as indicated by the graphic over the next year. And again, you typically see high latitude blocking in the Greenland with a large upper level ridge, which alters the long wave jet stream pattern with a mean trough over the eastern U.S. and a mean upper level ridge position over the western U.S. So this is something we have to factor in, and I always do. I do some research and look at this stuff before going through and actually including this as part of my winter outlook this year. Additionally, we must look at the accumulated cyclone energy, which is known as ACE. And these are the ACE values courtesy of Colorado State University through the 7th of October 2020. I'm really interested mostly in the North Atlantic numbers. To date, we've seen a very active tropical season with 25 named storms. The average is 9.7. So we are well above normal. Not only in that category, but we've seen 9 hurricanes. The average at this point of the year is 4.9. We've seen 3 major hurricanes at this point in the North Atlantic season. Average is 2.3. Major hurricane days are slightly below normal. But the overall accumulated cyclone energy, that last column, is at 114.4, with the climatological average for this date, up to this date, is at 87.3. So you can see our ACE values are definitely running above normal. Now, ACE includes both intensity and duration of tropical cyclones in the Atlantic Basin. So the formula includes both how long the storm lasts as well as its intensity. So we are running above normal for the accumulated cyclone energy. This is the ACE in the winter season connection shown graphically. I added these this year. The graphic on the left shows higher than normal ACE and the following winter's temperatures, the departures from normal in degrees Fahrenheit. Notice that most of the country is enshrouded in yellow coloring, which indicates milder than normal temperatures on the order of 1 to 2 degrees Fahrenheit on average. Meanwhile, the graphic on the right shows lower than normal ACE values in the following winter. And when you have a lower than normal ACE, look at the blue shading along the eastern seaboard from the southeast all the way up the east coast through the mid-Atlantic. A below normal temperature departure tendency when you have lower than normal ACE values for the following winter. Here's a look at ACE and the winter season connection for above average hurricane seasons in the following winter. Now we're facing this year. We have an above average, very hyperactive hurricane season in the North Atlantic, and look at the orange shading, those above normal temperatures extending from the Gulf Coast up into the mid-Atlantic, Virginia into Maryland and Delaware. In this case, the southeast ridge was abnormally strong. So you can see when that ridge really gets stronger out over the western Atlantic during the winter months, on the backside of it, you get that mild southerly and southwesterly wind flow and anomalously warm temperatures. And this is after above average hurricane seasons. So just a quick summary on the ACE East Coast winter storms. The lower the hurricane season ACE, the greater the likelihood of a higher number of East Coast winter storms. This really has to do with the conservation of energy. But this is, when you have lower ACE, you have more available potential energy, an abundance of it the following winter. The higher the hurricane season ACE, the greater the likelihood of a lower number of East Coast winter storms, and because that's mainly due to the fact that there's a reduction in available potential energy in the winter season, since there's been so many tropical systems during the hurricane season that have used up that energy. So as of 7 October 2020, we are running above normal thanks to this very active North Atlantic hurricane season. Again, there's our current ACE value as of the 7th of October 2020 at 114.4. The average is 87.3. So a higher than normal ACE value indicates less potential energy available for East Coast winter storm development, and most likely will result in the outcome of a lower number of winter storms. Now, this is only considering ACE, and ACE alone. The southeast ridge, when you have above average ACE hurricane season, the following winter typically sees a stronger southeast ridge. And if that's the case, we would expect the southeast ridge to be the main synoptic player this upcoming winter. Just to show you an example of East Coast winter storm activity, this is from Cornell University and NOAA. Basically, the graphic on the left shows the year and the number of East Coast winter storms and the strong East Coast winter storms. And the image on the graphic on the right there shows how the number of storms and stronger East Coast winter storms varies. You see the peaks, you see the valleys over the years from 1950 to 2020. Generally, the classification for a strong East Coast winter storm, ECWS, sustained wind speeds exceeding 52 miles per hour. But again, note the cyclical nature of the East Coast winter storms. They go up and down. That graphic on the right shows it. Again, some winters you have more than others. Some winters you notice a major drop-off in the number of storms. For example, from 1980 to 1985, you're dropping off in 1982 from 15 storms for that winter, dropping all the way down to less than 5 within the next year or two. So there's a lot of ups and downs to a cyclical nature here to East Coast winter storm activity. Cornell University, that's a great website to continue to monitor this, the number of East Coast winter storms a year, as well as strong East Coast winter storms. Additionally, for the outlook, we have to again consider the polar vortex, stratospheric warming events. The graphic on the right with the big red arrow pointed to it, that stratosphere undergoes rapid warming. Those red and white colors on the graphic on the right, those are indicating abnormal warmth in the stratosphere, which is the layer of the atmosphere above the troposphere, the second layer of the atmosphere. So all the way up to 10 millibars, so well above the surface, you get this rapid warming to occur, this rapid stratospheric warming. And just by virtue of that, you get changes in the long wave jet stream pattern and configuration. The polar vortex will either be displaced or weaken. If it's displaced off the polar areas, sometimes you get extremely cold air, anomalously lower heights in the mid-latitudes, extremely cold air, and a direct connection from the Arctic into the U.S. This allows for extremely cold air to dislodge into more southern latitudes, and it could be a case of record-breaking cold, for example. Arctic amplification is another term that I like to throw in every year because this is basically a warmer Arctic leads to greater instability in the overall long wave pattern with unstable waves. You typically get more of a abnormal jet stream configuration and get more unstable polar vortex to boot. So this is something we got to keep an eye on, is the strength of the polar vortex this upcoming winter, as well as the stratospheric warming. Here's the science behind the polar vortex. The graphic on the left shows a stable polar vortex, all the cold air being locked up over the Arctic latitude, higher far north latitudes, the Arctic areas. The graphic on the right shows more of a wavy polar vortex where it's weakened or displaced off the poles, and you get more of a general dip in the jet stream and colder than normal temperatures with a weakened polar vortex into the lower 48, into the U.S. This is an example of the polar vortex and what stratospheric warming can do. The graphic on the left shows Chicago's lakefront, Lake Michigan, frozen completely over. This was the late January, early February 2019 polar vortex. It was weakened significantly, the polar vortex, and was displaced off the poles into eastern Canada. And we had just unbelievable cold that hit Minnesota, Wisconsin, Iowa, Illinois. They got the brunt of it. Wind chills there in the pink shading on the graphic on the right, negative 50 to negative 60 degrees Fahrenheit. You can see on the image on the left shows all the heat trying to escape from below from the water from Lake Michigan there, the parts that are still not quite frozen yet. And by the way, I want to give credit, Dr. Judah Cohen, his blog, type in AER, Arctic Oscillation, and it'll bring up a really good website that you can check. He does weekly blogs, Dr. Cohen. He's really amazing. He always talks about the polar vortex and a bunch of other factors of what's to come in the winter ahead. So please take a look at him. Here's an example of one of Dr. Cohen's graphics showing you the mean polar cap height. The warmer temperatures are indicated by the salmon colors. And what happens is you get this troposphere, stratosphere, troposphere coupling. So warmer temperatures descend from the stratosphere to the troposphere. But in general, you get sometimes we get this mixing. The wave activity flux can result in very cold temperatures at the surface during a weakening or displaced polar vortex. So we've got to keep an eye on the polar vortex this winter. Here are my amplifying thoughts for the winter outlook, the 2020-2021 winter outlook. There's competing factors every winter. There's no doubt about it. For example, you could have a negative NAO versus a milder MJO phase, or a positive NAO versus a colder MJO phase. I talked about constructive and destructive interference in the past. How is the timing and alignment of all these teleconnections in producing either a colder or warmer than normal winter? If all these teleconnection factors line up at the same time, you could have increased probability for more extreme weather in the winter. Extreme cold outbreaks, for example. Extreme warmth with a more dominant southeast ridge. The past couple winters, honestly, the Madden-Julian oscillation, MJO, has been the king. So which of the factors will predominantly influence the weather this upcoming winter? That's the golden question. La Nina will be a major factor in this winter's outlook. And one thing I didn't mention is the strength of La Nina also matters. Whether you have a weak, a moderate, or a major La Nina, that is very important too, to look at that strength of La Nina. So we're keeping an eye on that as well here at Spot On Weather. Now, La Nina winters typically see, again, warmer and drier conditions across the Mid-Atlantic region. But again, remember this, not all La Nina winters are exactly alike. Just like Edward Lorenz once stated, there's always a little bit of chaos in everything in the atmosphere. If a butterfly flapped its wings in Brazil, just that motion of the wings flapping could have that perturbations in the air could actually impact weather in another location, thousands of miles away from Brazil, for example. So there is some chaos that still lingers, even in these climate models. When you see the forecast for seasonal forecasting, there's always some wild cards. I will cover that here in a minute. Additionally, will we see the mean trough? Where will that be? Will that be further back to the Midwest? Last winter, we saw a repetitive formation of storm systems that tracked from the southern plains into the upper Midwest. And the East Coast was in the warm sector of most storms last winter. So we really have to take a look at that mean trough position where the colder air is versus the southeast ridge, which typically you see that southeast ridge off the southeast coast, and it does impact our weather and bring milder air in every winter pretty much now. Those positionings of those main features, synoptic features, are very important. Also, the MJO, Madden-Julian oscillation phase, and the amplification of it. They're extremely important in the winter outlook, phases 1 to 8. I kind of covered that a little bit, with phases 8 through 2 being cold in the east, below normal temperatures, a dip in the jet stream, as well as phases 3 to 7 being the milder phases of the MJO. And additionally, the polar vortex strength and position must be factored into the outlook. So these, again, are my main focus points for this year's winter outlook. Here's my weighted factors. So I looked at all these factors. So let's just break these down briefly here. La Nina is forecast more than 70% probability of this happening for the upcoming winter. Pretty much all the climate models are indicating this. We're currently in La Nina conditions with below normal temperatures in the Nino 3.4 region. So with La Nina, we're expecting above average temperatures with below normal precipitation. With a La Nina winter, that's typically what we see here, Southeast Virginia and the Mid-Atlantic. Low solar activity, now that leads to increased frequency of high latitude blocking and a tendency for the North Atlantic oscillation and Arctic oscillation, NAO and AO, to be negative. Now this would favor below average temps with above average precipitation across the Mid-Atlantic and Southeast Virginia. With an above average ACE, which we have this year, typically leads to above average temperatures and below average precipitation for the Mid-Atlantic and Southeast Virginia. The teleconnections forecast, I took a hard look at the MJO, the AO, NAO, and PNA. And generally, all those teleconnections are favoring above average temperatures and below average precip for the Mid-Atlantic and Southeast Virginia this winter. I am looking at the prospects, and some of the longer range models are already indicating this, that there could be a weaker polar vortex this winter, which that would indicate below average temperatures, more of an amplification, anomalous configuration to the polar front jet stream. And we could see occasional intrusions of Arctic air as a result, below average temperatures and above average precip, trough in the eastern U.S., with a weaker polar vortex. All right, so I looked at all this. This is the Southeast Virginia winter outlook this year, 2020-21 winter outlook. I'm expecting above average temperatures and below average precipitation, including below normal snowfall. Now, December will feature mainly mild temperatures and dry conditions. It looks like another mild Christmas this year, at least at this point in time. The greatest probability for snow and the coldest temperatures looks to occur between the 1st and the 15th of January 2021. And we are expecting minor snow events, nothing major, less than 3 inches total this winter. Again, the average for Hampton Road cities is 7 inches, so we're not expecting a big winter as far as snow this year. Now, I dissected the La Nina conditions to come to this conclusion. I looked at the polar vortex forecast, teleconnections, solar activity, and the accumulated cyclone energy, the ACE, in determining this winter's outlook. La Nina, the teleconnections outside of the PNA, and the ACE values all support above average temperatures and below average precipitation for the Mid-Atlantic and Southeast Virginia, while the polar vortex will be in a weakened state, is what we're looking at right now, along with the PNA being more of a positive PNA and low solar activity. They all favor below normal temperatures and above average precip for the Southeast Virginia and Mid-Atlantic area. So I looked at all these factors. I weighted them on a 5-to-3 ratio. For example, I did 5 factors are indicating a mild winter with minimal snowfall, while 3 of these factors are indicating a colder winter with more precipitation. Not necessarily snowfall, but more precipitation as a whole, which increases your probability, right? Below normal temperatures and more precip would increase your probability for higher snowfall for the winter. So I got a 63% probability is what my conclusion came to on this. 63% probability of a milder winter with minimal snowfall. So I'm going with the majority on this forecast this year. Now the wild cards. We can't forget to discuss the wild cards. Again, Edward Lorenz chaos theory, look it up. Nothing is perfect in the atmosphere. Again, the smallest perturbation can really yield many widely differing outcomes. So first wild card is no 2 La Nina winters are exactly alike. There could be, a La Nina winter and something might throw off the typical La Nina winter pattern, for example. If La Nina, for example, ends up weaker than expected, we could see near average temperatures and more snowfall. You never know with these wild cards. If the MJO, NAO, the AO, and PNA all align in a specific way, we could see a colder than normal winter. So at this time, here at Spot On Weather, we're not expecting that to be the case. We are expecting low solar activity. That could also play a major factor. We can't discount that research that has been put in about the high latitude blocking and the potential for colder than normal temperatures across the eastern U.S., a negative AO and NAO. So again, this is the conclusion we came to for the winter outlook for the 2020-21 season. Above average temperatures, below average precipitation, and below normal snowfall. That wraps up the 2020-2021 winter outlook. Here's where to find us on social media. I'm really hopeful that I'll get a little more available time to do more videos now that we're heading into, we're in the fall and especially the winter. I love to share weather information with everybody, but here's where to find us. I really hope you enjoyed this video, and again, if you love snow, I love snow. I hope we get a cooler than normal winter with above average snow. But right now, if you look at all these weighted factors here, the way I dissected this thing, the 5-to-3 weighted ratio, it just looks like it's going to be an above average temperature and below average precipitation type of winter. It looks to me like the southeast ridge will be more of the dominant player, with milder than normal conditions stretching from Florida all the way up through the mid-Atlantic, up through D.C. The New England states, they're far enough north that they may see more of a influence of colder than normal air coming with a trough dipping down from Western Canada across the Midwest to the New England states. So further north, they'll probably be closer to average for temperatures and snowfall. But down here in Virginia, in the mid-Atlantic, we're looking at a milder winter. I will take a look at things again. I'm constantly looking at these conditions and determining the outlook. I will look most likely in December at making an updated winter weather forecast or winter weather outlook. So stay tuned for that. Awesome. I really appreciate your attention. Thank you for subscribing to Spot on Weather, and I wish everybody a great day.